Hey everyone, my name is Issa, and today I want to talk about loops in C++. So let's get right into this. Now, a loop I want you to visualize as kind of like a circle. So if we have a car, it's my car, some wheels, and we are driving in a circle. At some point in the circle, we are going to come back to our starting place. That's kind of how circles work. If you drive around the globe in a straight line, assuming there's road, you'll come back to where you came from. And we can apply this analogy to coding. So in code, the compiler runs from top to bottom. So the first thing it does is go to the opening of the function, and it goes all the way down to this return 0. Now sometimes we want to repeat instructions being code. So let's say here we want this section right here to be repeated. So we want the program to come back to the beginning and run down again a second time. And then loop again, go down a third time. Or however many times we want that instruction to run. So how do we do this? Well, let's make an instruction. So let's print hello world to the screen. This is a very simple input-output little project thing we do. So if we want to print hello world multiple times, well, we could just make multiple hello worlds. Problem solved, right? Well, not really. This video is about loops, so we want to use some loops to do this. And hopefully you'll see why loops are actually quite important. So let's make a loop. Now there are a couple different types of loops. So we're going to talk about for loops or incrementing loops. And then later on we'll talk about while loops. Now let's start with the for loop. So what is a for loop? Well, it's called an incrementing loop because it counts. Incrementing, we could also say a counting or a counting loop. So it counts. So let's make a for loop, and then we'll talk about the anatomy of a for loop. So I'm making this. This first part's what's called a counter. So you notice it's an integer, so it counts 1, 2, 3, 4. We want integers. We don't want to use doubles. I mean, I guess you could technically. Next part is the condition. The condition is, well, when do we stop? When do we end the loop? When do we continue with the rest of our program? So in this case, let's do 5. Let's print 5 times. So now let's take this line of code that we were just using, and let's put it here. So now it prints 5 times. And the way this works is our counter is 0. So the very first time we loop, I is 0. At the end of the loop, we increment the counter. So after all this code runs, we come back to the top, we make I 1. So I is 1. And now our second time going down, I is 1. And this keeps happening until I is no longer less than 5. So when I is 5, 5 is not less than 5. Thus, we are done. The loop doesn't run anymore. So really the key to loops is this condition, this conditional statement. This has to evaluate to true in order for the loop to run. That's something that I don't think gets talked about enough or mentioned in class when they talk about loops. The reason a loop runs is because of this condition. That's the only reason it runs. And it doesn't have to be a counter in here. For a for loop, you generally do want it to be a counter just because that's how a for loop works. But it doesn't have to be. It could be something completely different. And then you could just counter for something else. So that's kind of the for loop. And I'll make a quick little anatomy of the for loop. I do have a website up, the link's in the description, where you can see notes that I prepared for this video. So you can kind of get a little sneak peek at what's to come. There's also on other topics, so variables, all sorts of things. Check it out. It's linked in the description. Really cool little notes resource thing. Anyways, back to the thing. So anatomy of for loop. The first thing we have is a counter. which is counts how many times we have looped. The next part is the condition. When do we stop looping? And then the third part, it's really just incrementing the counter, aka adding 1 for every time we loop. Wow, I cannot type today. That's okay. And the counter. Okay. Now, the next type of loop that we want is a while loop. And the reason this is not enough is because this only loops a predetermined amount of time. So if we want to loop 5 times, we can tell it, hey, loop 5 times. But what if we don't know how long we want something to loop? And that's kind of where a while loop comes in. So a while loop is a true loop, I would say. And the reason I say that is because technically a loop, like fundamentally a loop is defined by its repeating over and over and over again. Something like this is akin to just, running the code multiple times. I mean, this is just a semantics difference. I like to think of it as the true loop. It is what it keeps running until it doesn't run. While this is, predetermined, it'll run this many times. So, got a little philosophical there. So if we make this while loop, let's do something that you should never do, which is make an infinite loop. So let's make it. Let's make it. I mean, we can do whatever we want. This is an IDE. So run this. It keeps looping, right? Like there is no endpoint to this. This is gonna keep looping forever and ever and ever and ever and ever and ever and ever until the end of time, or until my computer runs out of memory. So this isn't the greatest example of a while loop because nobody would use this. This program will never end. So if we ever want to end it or do something else in this program, we can't. So not the greatest example of a while loop, but it gets the point across. And that's kind of the idea. It keeps looping. That's what it does. It loops until this is no longer, until something changes. So let's change it a little bit. So I'm going to just I'm just going to copy this code over. And we're going to change it. So instead of doing this, let's make a Boolean. And I'm going to call it flag. We'll set it to false. So this part inside the while is the condition. This is the same thing that was in here. So we need some sort of condition. So my condition is going to be while flag is false. So flag is this variable which is set to false. So while false is false equal to false? Yes, that's a true statement. Thus, this loop is going to run. If we change it to flag equal true, this is not going to run because false is not true. You see how that works? It's a little trippy. I still sometimes get myself tripped up when I'm working with these kinds of flags. But essentially what we can do is we can say, hey, keep looping. So this right now is an infinite loop still. But what if we say at the end flag equal false or equal true? Sorry, got to flip it. Now it only runs once. So in this case we know it only runs once because we're stopping it after the first loop. But what if we change it? Let's make it variable. Let's make it, loop run multiple different times. So I'm gonna use input to stop it. So I'm gonna say string input, and in here I'm gonna say let's use kin. If you haven't if you're not familiar with kin and user input, go check out my video on input and output in C++. This is kind of important for what I'm doing right now. Essentially, we're just pulling in input from the keyboard. That's all it is. But you should definitely watch that video still. So if input is stop, so if we type in stop, all lowercase, we should we're going to set this flag to true. So essentially, what we're doing is this code right now, it's waiting for input. If I type anything, it's going to keep looping. So you see, it's going to keep looping until we write stop. When we write stop, that breaks this loop. This condition is no longer valid. We're going to exit the loop. And that's kind of the idea with while loops. That's the fundamental principle of a while loop is we're going to keep looping until something happens. In this case, it was the user inputting stop. But there's other examples. So, for example, I have a program I created when I was a tutor at my college. This is my logging application. So you'll see it's a window. That's pretty cool, whatever. But notice that this program is still running. Right now, it's running. I could stop it by clicking this button. Notice that this one has stopped. You can't click this button anymore. And that's like we want this window to be open because we're still using it. But when we're done, we can just click close. And you see how it ends? So that's kind of where a while loop. And you can actually see in the code here, there's a while loop. Don't worry about this GLFW, all that stuff. Essentially, it's saying while we haven't closed this window. And you can kind of begin to see where while loops come up. They're kind of all over the place. Web servers, you know, when you send a request to Google, there's a server that's just constantly waiting for requests. So that's kind of the idea with while loops. There is one more kind of while loop. It's like a different flavor. It's not really its own loop. It's called a do while loop. I know, mind blowing. And the idea behind the difference between them is really, really, really small. There's just like one tiny difference aside from syntax. So let's make one. So I'm just gonna copy all this stuff and I'm gonna comment it out so you can reuse it. So now all I'm gonna do is I'm gonna take this and I'm gonna put it to the bottom and then I'm gonna add the word do in front. That's it. That's the difference. Boom. Do while loop. Easy. Easy peasy. So if you understand a while loop, you understand do while loop. It works exactly the same. So, blah, and then stop, and it works. Right? So what's the difference? Well, the difference is that all this code gets run before it checks condition. A while loop checks condition, then runs. Remember, programs run from top to bottom. So that's really it. I don't know. I'm sure there's some under-level efficiency reason why you would use one or the other. Personally, it kind of comes down to principle for me. If I'm working with something like think like an ATM machine. So an ATM machine, you go up, pull up, you put your card in, and it gives you a menu. And then on that menu, there's like options for the buttons. It's like, hey, do you want, withdraw, deposit, whatever, and you click that button. So for me, if I were to design a menu like that, I would use a do while loop. The reason, because you can't pick an option. You can't pick an option without knowing what the options are. So we should see the options. So you could like have a print. You could use count and just print out a bunch of options and then check, hey, what did they press? Yeah? So that's kind of the idea, in my opinion. You gotta... So that's just how I would choose between using a do while and a while loop. Otherwise, they're virtually identical. You could probably go a day in your life without using a do while. Be totally fine. The last thing that I want to talk about is a for each loop. Okay, for each loops, they kind of require knowledge about arrays. So if you haven't seen my video about arrays, everything you need to know about arrays in C++, you should definitely watch that. Maybe go watch that and then come back and finish this video out. So an array is a container. Just quick summary. So if we make an array, we just need an array for this to work. So I'm going to make an array. I'm going to put some values in it. Now, when we loop with so we can loop through an array using a normal incrementing loop. So we can say int I is 0, I less than 5, which is the size of the array, I++, and then we can print array at I. So that's pretty cool. But it requires that we know and we manage, we mentally think about how big our arrays are. We could use vectors. Vectors have stuff like vector.size, which tells you the size. So you could use that in this condition. But there's an easier way to work with this, and that's using a for each loop. So I'm going to make a little divider. I'm just going to make a little header for everything. So I'm going to say, oops, what is that? What did I even copy? That's so weird. Okay, I'm going to say incrementing for loop. And then I'm going to take this and I'm going to say for each for loop. And now let's make a for each loop. So for each loop, it's quite simple compared to a for loop, like in syntax. So all we need is an element. So like, for example, this is an int array. So I'm going to make an int element. And then I'm use a single colon. And you're going to put the name of the container being the array or the vector or whatever. So these are going to do similar things. So if I count element, you'll see that these work they look like they're working exactly the same. Well, what's the difference? Well, for one, this is way easier to read. Hey, for every element inside an array. Hey, loop 5 times, and then this is the array. Well, what happens if we loop outside the array? And this is something that you'll see that we kind of get gibberish, right? But we can't make that mistake with a for each loop, right? Like, it's gonna loop to the end of the array, and that's it. And that's kind of the advantage of a for each loop. But the problem is with the for each loop that we're not actually working with the array like we are up above. So like here, we have an array. 1, 2, 3, 4, 5. Those are our numbers. And we are going to each one. Right? And we can choose where we want to stop. We want to stop at 3. We can just say, hey, loop until 3. And then it's going to stop at 3. So on. We can't quite do that with an array, with a for each array, or for each loop. But, and that's that's like a point to regular incrementing for loops. But there's also one downfall to for each loops. They don't actually work with these numbers, this part of memory. Like these are all in memory in the array. A for each loop makes a new part of memory. So it makes a new one called element, and it copies the value into element, and then we work with element instead of working with the array directly. So this is nice because what if we want to just read stuff? We just want to look at, hey, what's in this position. But from an efficiency point of view, we're doing an extra instruction for every single element. So we're doing a copy here. We're doing a copy on this one, a copy on this one, a copy on this one, a copy on this one. So from a performance standpoint, incrementing for loop is actually way better because we're just working with the memory itself. Now, there is a way around this, and this is beyond the scope of this video, but I'm just going to toss it in here. You could do this. This is an ampersand. It stands for a reference. We'll talk about references. I think I actually talked about it in my pointers video. Go check that out as well. Where instead of making a new thing, we can just point element to each of these. But at that point, you might as well just use this. So that is loops. That is, pretty much the basics. If you do have any other questions, be sure to leave a comment. I'll respond there. I'll make a video. I'll probably make a video if there's enough, confusion, whatever. Also, join the Discord. So we have a Discord server, and it is full of people, just computer people, gaming people. So it's a great community. Some of these people are my classmates. So I went to college with these guys. They're also doing computer and coding. So if you have any questions, either I or my friends can help. It's also just a wonderful group of people who just love hanging out and playing games. So if you ever want to find squads for games, you can find it there. Alrighty, well, have a good day. I'll see you next time.